Hello guys, my name is Nikander, I'm a professional blockchain developer, and in this guide we'll see how to work with primitive types string, string builder, slice, cell, and builder on Ton blockchain. Let's get started. First, let's create a new project using the Blueprint framework. Open VS Code, type npm create Ton latest. Name the project primitive types 2. The first smart contract name is strings. Select a Tact empty contract and wait for a few moments. Navigate to the project directory. cd primitive types 2. Clear the console. Great. Now we are ready to begin writing the code of our smart contract. Inside the contracts folder, open the file called strings. We can declare a string using a string keyword. We can initialize a string with any Latin character or emoji or Unicode character. There's no need to initialize variables right away. We can initialize them later in init function. Let's declare a variable i1 of type int and initialize it with the integer value -1, 2, 3, 4, 5. Declare another variable i2 of type int and initialize it with the integer value 7,250,000,000, which represent an amount of coins equivalent to 7.25 ton coins. We can convert the integer value i1 to a string using the toString method and assign it to the string variable as 3. Also, we can convert integer value i1 to a floating point string with 3 decimal places using the toFloatString method and assign it to the string variable as 4. To get a string representation of coins, we use toCoinsString method. To combine multiple strings, we use StringBuilder. Let's declare a StringBuilder and initialize it by starting a new string using the beginString function. Append the contents of the string variable as 1, then append the string your balance is, and append the contents of the string variable as 5. Convert the contents of the StringBuilder object as b to a regular string and assign it to the string variable as 6. The final step is creating a getter function for the s6 variable, so we can check the content it holds. Now we can build the contract. npx blueprint build. Great, we have no errors. Let's test it and see what content holds s6 variable. Open the file inside the tests folder. Get the value of final string by calling the getFinalString method on the strings object, which represents an instance of the strings contract deployed on the blockchain. Log the final string value. Now we can test it. npx blueprint test. Great, as you can see, the final string value is hello world. Your balance is 7.25. That's exactly what we expected. We can move on to the next primitive types. Type npx blueprint create. The contract name is slice cell builder. Select Tact empty contract. OK, clear the console and open the contract file. So, what are those types? Cells is a low-level primitive that represents data in Ton blockchain. Cell consists of a 1023 bit of data with up to 4 references to another cells. Cells are read-only and immutable. Builders are immutable structures that can be used to construct cells. Slices are a way to parse cells. Let's see how it works in real life. Declare a storage variable named storage of type cell, which will hold data on the blockchain. In the init function, declare an address variable, coin address, and set it to some random token on the Ton blockchain. In my case, I use Anon token. Declare a builder object that prepares data for storage on the blockchain by setting an address and an associated monetary value to be stored within a cell. In simple terms, we just put some address and int value to the builder. I use some random int value that could represent my balance in real life. Convert the builder to a cell with asCell function and assign it to the storage variable. Define a getter function named coinAddress that retrieves the stored coin address. We convert the storage cell into a slice, load the stored address from the slice, and return it. Define a getter function named coinNumber that retrieves the stored number of coins. Convert the storage data into a slice. The load address function is used to advance the position within the slice to the location of the coin's data, ensuring it's read correctly. Then the load coins function reads the coin's data as an integer and returns it as the final result of the function. Define a receive function, change coin values. In this function, we update the storage variable with new values. It sets a new address, in my case of token scale, and a new number of coins, in my case 6/7. Then creates a new cell object and assigns it to the storage. Now we can build the contract. npx blueprint build. Select the right contract. Great, we don't have any errors. Now we can write some tests. Open the slice cell builder test file. Create new test. Should change the values because we'll be changing the values. Retrieve the initial values of the coin number and coin address from the slice cell builder contract. Print out the initial values of the coin number and coin address. Trigger a message to the slice cell builder contract to change the values, simulating a change in the contract state. Retrieve the new values of the coin number and coin address from the contract after the changes have been made. Print out the new values of the coin number and coin address. Check that the values of the coin number and coin address have changed after the contract state has been modified. Let's run the tests. npx blueprint test. Great! As you can see, we had the initial number of tokens 100,000 and the initial token contract, the token Anon. Then we have changed it to 6/7 and the token scale. Awesome! That's it for today, folks. Thank you for watching. If you found this video helpful, don't forget to like, share and subscribe for more content like this. Your support means a lot. See you in the next video.